Good evening, everyone. I am Prepsa Kayastha, and today I will be talking about our journey with horizontal sharding. So in today's session, I will be going through the background of what led us to choose horizontal sharding, and a brief introduction of what horizontal sharding is, when to use it, and how to implement it, and a brief demo, and also the challenges that we faced during our implementation. So let's begin. So let's consider a scenario. We want two separate environments, staging environment and production environment, which are both independent, and we want staging environment for previewing and testing our app. It has both the environments has back-end, front-end, database, everything, right? So they are both independent, but we want the staging environment as a sandbox. I'm only using staging and production as names for convenience. So staging environment, the admin of the app should be able to create new records, edit the records, and delete the records. And if they are happy with what they see in the staging environment, if front end looks good, the record looks good, the data looks good, then they would want the ability to sync that record or database to the production environment and push it live, right? So they would want the ability to sync individual records. They would want the ability to sync a whole model at once, and then also batch sync the records. They would want to pick and choose which content they want to sync. So that's the scenario. And we considered a lot of alternatives for this scenario. There could be a preview feature for the production environment itself without creating a separate environment. There can be data dumping as a whole, but those alternatives did not actually fulfill the requirement for this scenario. So that's where sharding came in. So talking about sharding, sharding is a strategy to partition the large data sets into different shards or manageable chunks, which is also known as shard, to make it more manageable and more easy to access. So sharding, we can partition the data vertically or horizontally. Vertical sharding would mean to partition the data split the data into two or multiple shards with column on the basis of columns, right? So in the original table we have customers data, first name, last name, and city, and in the example we have created two shards. First shard contains the first name and last name of the customer, whereas the second shard contains the city. So that's sharding vertically, right? So in horizontal shard, the sharding is done, the data splitting is done by rows. So if we have a large data set, we only have 4 data here, but if we had large data sets, we can split the data. Both data shards would have the same attributes, but the data will be partitioned by row. So horizontal sharding I've already talked about. We split the data by row, and all of the attributes and the schema of the database would be the same. So for example, if we are to create an e-commerce website like Amazon, and we have hundreds and thousands of products, we can use horizontal sharding to split the data on the basis of category. One category could be clothing, one category could be electronics, one category could be books, and so on. So in our scenario, we are trying to split the database on the basis of environment. So I've already mentioned some of the ways we can use horizontal sharding. One is when the data gets too big, and when it gets more cost effective to horizontally shard than actually vertical scaling of the database. So we can use horizontal sharding, and if we have high traffic, if our website is getting high traffic and we want to distribute the load evenly in evenly throughout our database, we can use horizontal sharding. It helps us do that. And also scalability. So in horizontal sharding, we just add on more servers as we need, and it's basically infinite scaling, right? And finally, custom requirements such as hours. So we can use horizontal sharding there as well. So how do we implement horizontal sharding? So first we have to configure the database YAML file. In our normal database YAML file, we only have one database, but for horizontal sharding, we can specify multiple. I've specified primary and secondary database here for development environment. And next step would be to connect the shards to the model. We can do that from the application record by using connects to method, right? So we are specifying two shards here, default and secondary shard. Default shard uses primary database and secondary shard uses the secondary database. We are using it in application record because it will be inherited in all of the models. We can do that, or we can create a new class. Here there is shard record, and we can inherit this shard record for specific models that we want to shard. So the next step after connecting it to models would be to switch shard when we want it on the basis of our needs, right? So to do that, we can use connected to method and specify the role and the shard that we want to connect to. Here I'm trying to create a product named default product 1, and I'm trying to create that product in shard default shard, right? So the output would be a new product in the default shard. However, if you want to, if we try to search the default product 1 in the secondary shard, like I'm doing here, it won't be able to find any product by that name, and then it will give nil return. So if we try to search it in the default shard, though, we will find the default product in the shard. So to recap the scenario again, before the demo, we wanted two environments, one for previewing and testing and one for live, right? So in staging environment, we will be creating the products, updating the products and deleting the products, and we want to sync all of that changes in the production environment. So I'll switch, let me switch. So I have two environments here. This is for primary shard and this is for secondary shard, right? Okay. Let me destroy some of the products in secondary shard before we begin. Okay, so secondary shard has only one product, oscillating stand fan, and the primary shard has 4 products, right? So if you want to, let's say, sync only this product, Samsung S25, right? We can go to view and then sync this product, and then once, okay, it has given successfully sync. Let's check. So it has already synced, right? So to do this, I've not done anything fancy, just done whatever I mentioned in the previous slides, just connected to the shard and then created a new product from there. So if I want to sync all of these products at once, all of the products, everything in this product table, I can just do this, and let's see. So these are all synced now. So that's how horizontal sharding can be used for our scenario as well. So while implementing this horizontal sharding, some of the challenges or things that we had to consider were these things. So let's go through this. First one was to avoid duplication while syncing. So how can we do that, right? So we have similar, we have the same structure, same schema in both the environments, in both the shards, and it's easy if it's easy for new products to be synced, because there is no existing product with the same name or description or price, right? So we can directly sync that and there will be no problem. But if we try to sync the first record here, ABC, and if it has been edited to ABD, then we will have trouble finding the exact simultaneous product in the secondary shard, right? So how can we do that? So to do that, one of the way is to use primary unique ID. For primary unique ID, we can use UUID or the unique ID of the primary shard. Here in this example, I've used the primary ID of the first record. So even if the other details are changed in the primary shard, we can easily find the corresponding record in the secondary shard and update it. Next thing we had to consider was handling callbacks. So if the model that you're trying to, if the record that you're trying to sync has callback, for example, if you have a user model and then you're trying to sync a user to production environment and it has a callback send welcome email. If we try to sync new users in the production environment, it will send welcome email to that user, right? So, but the user is already created in this staging environment and we have already sent the email, so sending the email would be like unnecessary notification to the user. So to avoid this, we can either skip callback when we are syncing. So we can use skip callback method and skip the send welcome email callback, right? And then reset the callback after we have already saved the user in the primary database. We can do it like this, but there's a there's a caveat in here. If we are, this is not thread safe basically. If we are trying to create multiple users at the same time, if we are trying to sync multiple users at the same time, this may cause some problems. So a better version, a thread safe version for this would be to use a condition for the callbacks. Here we are using skip sending welcome email. This is an attribute, and we can send this attribute while creating the user in the production environment. We can set this to true, and then it will skip the send welcome email callback. So one of the ways of handling callbacks is using the attributes. Next is deleting the records, right? So we need to if we delete any record in the staging environment, we would need to be able to track the record in production environment and also delete there. So how do we do that? We can either use soft delete and then track it like that, and then use a background job to asynchronously delete the deleted records later at a later time in the production environment, or we can either we can do the simultaneous delete. Whenever a record is deleted in the staging environment, we can use a callback and then delete the corresponding record in the production environment simultaneously. So these are some of the things that we had to consider while implementing the sync feature, right, in our scenario. And these are the references that I've used to compile this presentation. If there are any questions, please let me know, and please let us connect in LinkedIn. Here's my QR code. Thank you.